Okay, so here we are going to take this fraction, you can see it here, and we're going to try and change it so the denominator doesn't have a surd in, but it consists only of a rational number. So that's with an integer denominator. This is called to make the denominator rational. So we are going to rationalize the denominator. And the reason we might do that, we've said in a few previous videos that, you know, if we can change this into something like fifths, then when we're adding fractions, you know, we've been trained so much, haven't we, to try and get the denominators into the same value so we can go ahead and add them. And so wouldn't it be nice if instead of trying to do fractions with surds in, we could maybe change this fraction somehow into one like this, and then go about our normal business of adding fractions. So we're trying to come out of the surd world with denominators and into the integer world with denominators. And that's the kind of world which we understand how to add and subtract quite easily. So there is a nice little trick for this, of course, as there usually would be. But before we make the right choice about how to do this, let's just make a beautiful mistake. What if we decide that, there's a root 2 there, let's times the top and bottom by root 2, because we may have seen how to do that previously. So the top becomes root 2, but you see the bottom, sure enough, this stays as a root, right, 3 root 2, and the root 2 times root 2 becomes 2, but that doesn't really help, right? Doesn't really help. But the key message here might have stuck in your brain from one of the previous multiplication videos. If you have a number, an integer, and a surd, a nice little trick is to copy and then paste it. So let's do that now. Copy and paste it. So 3 plus root 2. And then just do a sign change for the piece that's been added or subtracted. And this is the key, right? This is what we're going to multiply the denominator, and then obviously to keep the fraction balanced, the numerator. So let's go ahead and get to it. The question is 1 over 3 plus root 2. Let's make sure we put that in a bracket, and we can change this into a different format by multiplying by whatever we want. But of course, remember, what we do to the denominator, we must do to the numerator, because then effectively we've multiplied it by 1, right? This is the same divided by the same, which is 1. So we're timesing the original fraction by 1, but we're going to change the format here. So let's go ahead and try that. On the top, quite an easy answer, right? That's just 1 times this, which is 3 minus root 2. The denominator, a little bit complicated, but you'll see that it becomes quite easy in the end. 3 times 3, so we'll go ahead and just do 3 times 3. I think I'll write the answer straight down. You can obviously do a grid method if you like. And now we'll do the next piece. 3 times by the negative 2. All right, so I think that's a negative answer. Negative 3 root 2s. Then we do the next piece. Root 2 times by the 3. That's interesting, right? Isn't that plus 3 root 2? And the final stage is the positive times the negative. Positive root 2 times by the negative root 2. Now that's going to be a negative overall. Root 2 times root 2 is 2. So look what's happened. As we scroll through here, the 9 will combine with the 2 here. 9 minus 2 is 7. And look at this. We've got 3 root 2 minus 3 root 2. Or negative 3 root 2 plus 3 root 2. That cancels each other out. So we get to this nice final stage, which is the numerator is 3 minus root 2. And the denominator is actually just the 9 minus 2, because these guys cancel out. And there we go. So we've managed to change the original fraction, which was this one in red. We've changed it into a fraction with just a nice integer on the denominator. And now this fraction might be easier to add to other fractions. And that's why we sometimes change the denominator into a nice integer number. One more question. Let's have a little look at it. So that might be, we'll try this again. So what do? We take the denominator, we copy and we paste it, but we do a sign change for the plus to the minus. And whatever we do to the bottom, of course, we must do to the top. All right, so let's just write that out. And I'm going to do this separately, right? We can take our time. We can do the numerator separately to the denominator. So the numerator, 1 minus 2 root 3, remember all in brackets times by the 1 minus root 3. And then the denominator will be, just get my pen on, the denominator will be the 1 plus root 3 times by the 1 minus root 3. Now we're thinking and hoping that that denominator goes into a nice integer number. So let's start with the denominator. We're going to do the, let me get my little pointer, the 1 times by the 1 first, and then the 1 times by the negative root 3, and then the root 3 times the 1, and then the root 3 times the negative root 3. There should be 4 pieces for the answer. So the answer here is the 1 times 1 is 1. 1 times the negative root 3 is negative 1 root 3, but we don't usually put the 1 right. The root 3 times by 1 is a positive root 3, and you can see what's going to happen. Root 3 times root 3 to give 3, but the answer is negative, right? Because we've got a positive here, positive times a negative. And can you see when we tidy those 4 pieces up, the 1 minus the 3 is the negative 2. And of course you can see it now, right? Negative root 3 plus root 3, these pieces cancel out, and we're left with just negative 2 on the denominator, as we wanted. But we need to finish off because we've got a numerator to organise as well. 1 times 1 is 1. 1 times negative root 3 is negative root 3. Now we'll just take our time. Negative 2 root 3 times by the 1. That should be negative 2 root 3. And finally, we've got a negative times by a negative, which is positive. So negative 2 root 3 times negative root 3, which is positive. So that's plus the 2, and then we've got the root 3 and the root 3. Okay, again, we'll just take our time with this. What I'll do is let me move this down to give myself a bit more space. There we go. And so what can we do? This is 1 minus root 3 minus 2 root 3. And can you see over here, that old root 3 times by itself just gets us back to 3. So this is 3, and 2 times 3 is 6. And finally we can tidy up because we've got 1 plus 6 makes the 7. And over here we've got negative 1 root 3, so negative 1 is where we start the number line. Subtract 2 more, that gets us down to negative 3. Negative 3 what's? Negative 3 root 3s. Whew. And so the final answer, of course, is when we put the 2 pieces together. So we are going to put the final answer now. Let me just zoom in a little bit so we can have it there. That looks good. The final answer would be the numerator, 7 minus 3 root 3, all divided by negative 2. That's a great answer.